Welcome to The Explainer. Today, we're diving into a new piece of technology that could honestly change the game in how we fight one of the most widespread viruses on the planet, dengue fever.
So, dengue is a huge public health problem, especially in tropical and subtropical countries. We're talking major outbreaks year after year that affect millions and millions of people.
And when you're fighting a disease like this, you're in a race against time. Getting a diagnosis that's early, accurate, and fast is absolutely non-negotiable. It's how doctors can help patients, and it's how health officials can get a handle on an epidemic before it spirals out of control.
But you see, there's a big problem right at the center of this fight. It's a real diagnostic dilemma, and it hits hardest in the very places that are most affected by the virus.
And this really lays out that dilemma perfectly. On one side, you've got these rapid tests. They're great because they're fast and simple. The problem, they're not always reliable. You can get false negatives, which is a big deal. Then on the other side, you have these super powerful lab tests that are incredibly accurate, but they're slow, they're complicated, and they're way too expensive for most local clinics on the front lines.
So what exactly is this powerful lab test? What is this so-called gold standard for spotting dengue?
Well, it's called RT-PCR, and the best way to think about it is like a genetic photocopier. It's amazing. It can find one tiny little piece of the virus's genetic material and just make millions and millions of copies until it's super easy to detect. That's why the World Health Organization says, yep, this is the best, most sensitive, most specific method for diagnosing dengue when someone first gets sick, which is exactly when you need to know. But, and this is a big but, here's the catch. This gold standard test just isn't practical out in the field. To run it, you need a whole laboratory setup. You need expensive, specialized machines. You need highly trained technicians to operate everything. And usually these labs are only in central cities, often hundreds of miles from where an outbreak is actually happening. And this is where things get really interesting. A new innovation has come along that aims to fix this whole problem by basically shrinking an entire PCR lab down and putting it inside a simple automated box. Okay, so to really get why this new tech is such a leap forward, let's first look at the existing system. This is the semi-automated way. It was definitely a step in the right direction, but as you can see, it still involved a whole lot of hands-on work. This workflow really tells the story, doesn't it? It's a four-stage process. A technician has to manually prep the sample, put it in one machine, then manually prep the reagents, then move everything over to a second machine. It takes a lot of time, it opens the door for human error, and it means you need some serious training to get it right. Now, compare all of that to this. This is the new approach, the POCKIT Central system. It's completely automated, it's all in one, it's designed from the ground up to be a true sample-in, results-out machine. Just look at the difference here. It's incredible. The user just adds the patient's sample to a little cartridge that's already preloaded with everything it needs, they pop it in the machine, and they press start. That's it. Seriously, the entire lab is now in the hands of someone with very little training right where the patient is.
But, of course, making something so incredibly simple raises a really important question. It's a question researchers had to answer before a device like this could ever be used for real.
Does all this automation, all this simplicity come at a price? I mean, did they have to sacrifice the accuracy that made PCR the gold standard in the first place? Is simpler really just as good?
The answer after they tested 60 human samples was a huge, emphatic no. They found that the two systems had 100% agreement in their results.
So let me just repeat that, because it's the whole point. They didn't sacrifice a single bit of accuracy to get all that simplicity. The new automated box was just as good as the complicated, multi-step, two-machine method. And the system also turned out to be incredibly specific. It correctly flagged all 4 types of dengue virus. But, and this is super important, it didn't get confused by other viruses that have similar symptoms, like Zika or chikungunya. It only finds exactly what it's supposed to be looking for. And get this, it gets even better. It doesn't just work on people, it works on mosquitoes too. This is a massive tool for public health officials, because now they can track the virus out in the environment, not just in sick patients. It lets them get ahead of an outbreak before it even starts.
Okay, so let's just zoom out for a second. What does all of this actually mean for global health?
You know, the researchers who developed and tested this technology, I think they summed it up perfectly. It's all about creating a useful tool near points of need. It's about putting the best tools right where they can do the most good.
This isn't just about a new gadget, right? This is about the real-world impact.
We're talking about empowering frontline health workers, giving them the gold standard diagnostics they've never had before. That leads to better, earlier patient care, and it gives us all a much better shot in the race against dengue. Oh, and here's a small detail that's actually huge. The reagents are freeze-dried, so you can ship them and store them easily without refrigeration. That is a total game changer for remote areas.
And that really leaves us with one final and kind of exciting thought. If we can successfully put a complex dengue lab into a simple automated box, what other diseases could be next? What other vital labs are just waiting to be boxed up and sent to the front lines?